Okay, this is the putting it all together video. Up to this point, we've looked at what A, B, and C do to the graph individually. Now we have to see what happens when you put them all together into one function. What does it do to the graph? This is a little bit of a longer video, so you might want to make sure, and it has a lot of information in it. Make sure you take careful notes on this, and make sure you understand all the pieces. You might have to watch things a couple of times to really understand what's going on. Okay? So we know that A is the amplitude, B is used to find the period. Remember, B is not the period, but it's used to find the period of the graph. C is the phase displacement, how it moves the graph left and right. So this stretches the graph vertically, this compresses or stretches the graph horizontally, this shifts the graph left and right, and this moves the graph up and down. So that's what all four of those things do. I'm going to do this as an example, through an example. I'm going to do all the steps here, and when you're graphing a function like this, you can go through these. You should go through these steps. They're a little bit long, so take your time, make sure you do it correctly, and then the graphs will make a lot more sense to you. So I want to sketch two cycles of the function y is equal to -1 plus 3 cosine 2 theta plus pi. Now, up till now, that doesn't look right in the right form from what we've been using. So you can make it into that. I put the -1 out here to the end. Okay, so I know that's my vertical translation, that's my sinusoid axis. Left the 3 there. Now, this is really important. If this is not factored, if B is not factored out of this, then you have to factor it out to do the rest of to find the rest of the information. I factor out the 2, so that 2 parentheses theta plus, and I divide pi divided by 2, so that's my phase displacement on the inside. Okay, so from the way the way the function is drawn right now, I can find the amplitude is 3. That's easy. The sinusoid axis is -1. Write that down. Phase displacement, it's been shifted to the left, pi over 2 radians. Okay. The period is equal to 2 pi over b. B is 2, so 2 pi over 2. So the period of our graph is pi radians. That's enough information to kind of get a rough sketch of it. I want you to really work on the accuracy of your sketch. So what I'd like to look at real quick is the untransformed cosine function, which you should be fairly comfortable with. Okay, cosine starts at a peak. It crosses its sinusoid axis at pi over 2. It has a minimum at pi. Crosses its sinusoid axis again at pi over 3, or 3 pi over 2. Then has a maximum 2 pi. So its period is 2 pi radians. But it has basically 5 critical values. It the starting point where it crosses the sinusoid axis, its minimum, where it crosses the sinusoid axis again, and its maximum. So it has 4 chunks of the graph. So when you're graphing them, you should make sure that you get these 4 points labeled fairly accurately. And notice also that my graph has a curve to it. It doesn't go angled to the points. It has a smooth curve going through all the transition points. So using that information, the period of this graph we just found was pi. So to find the distance from each of those chunks, each of those 4 chunks, and I'm going to call those are critical values. Maximum crossing the sinusoid axis, minimum crossing the sinusoid axis, and the maximum. Those are the critical values. So to find the distance between the critical values, you divide your period by 4. So that gives me pi over 4. That means each of the chunks of the graph is pi over 4 radians. So that helps me find where all of these critical values are. It has a maximum at 0, so that's one critical value. That's a starting point. It crosses, and that's not this function, that's without the phase displacement. Okay? So it has maximum here. I add pi over 4, that gets me the next, that's where it's going to cross the sinusoid axis. Okay? So I bring that down, add another pi over 4, add another pi over 4 chunk, and that gives me 2 pi over 4, or pi over 2, and that's the minimum. So maximum crosses minimum. Up here again, now pi over 2 plus pi over 4, that's 3 pi over 4. So that's where it's going to cross the horizontal axis again, or the sinusoid axis. Okay, bring that down, 3 pi over 4 plus pi over 4, that's 4 pi over 4 and pi. So this gives me the 5 critical values that the function has. Starts here, crosses, has a minimum here, crosses the horizontal axis again, the sinusoid axis, and then has a maximum at pi. Now I have to factor the phase displacement into that. So the phase displacement takes each critical value and moves it to the left pi over 2 radians. So it's shifted everything to the left pi over 2 units. So I take my first critical value was 0, subtract pi over 2. That means my graph starts at negative pi over 2. That's the peak value again. Okay? The other critical value was pi over 4. Subtract pi over 2, and that moves it, that graph has been moved over to negative pi over 4 units. Okay? The next critical value was pi over 2. Subtract pi over 2. This thing, subtract pi over 2, that gives me 0. So that's the third critical value. So the peak crosses its sinusoid axis here, minimum. So that's the smallest point. And then the next critical value is 3 pi over 4 minus 2 pi, minus pi over 2. That shifts it to the left, pi over 2 radians. So pi over 4. So now this is where it crosses the sinusoid axis again. And the last critical value was at pi. Subtract pi over 2. And that gives me a maximum pi. So it starts, it's maximum, crosses the sinusoid axis, minimum, crosses the sinusoid axis going up, and maximum at pi again. So now I have enough information to graph the whole function. Okay, I have a sinusoid axis, negative 3. I'm just summarizing everything we have so far. Sinusoid axis, y equals negative 1. Amplitude is 3. The period is pi. The phase displacement was negative pi over 2. That's all the information from this graph, or just straight out from the function. The critical values were found where I just showed you. You might want to review that one more time to make sure you understand how these values were found. Okay, so these are my critical numbers. So each of these critical numbers is where I put on that. If you're really good and you're using the grid lines of the graph, you can make each grid line one of these values, or every other grid line one of those values, depending on how it's drawn. So if you want to stretch it out a little bit or make it fit. But I'm looking for these critical numbers when I'm looking at your graph. Okay, so negative pi over 2, it's at a maximum. Or let me graph the sinusoid axis, negative 1. That's the easiest thing to draw. Okay, then I use my amplitude. From the sinusoid axis, I go up 3 units. 1, 2, 3. And that's the maximum that the graph goes. And the amplitude down from the sinusoid axis, down 3. 1, 2, 3. And that's the minimum that the graph goes. So I use those two pieces of information to get the upper and lower and the middle points. Okay? Now I'm pretty much focused on the critical values. So negative pi over 2 is at the maximum. Negative pi over 4, it crosses the sinusoid axis going down. 0, it's at its minimum. Pi over 4, it crosses the sinusoid axis again. And at pi, it's at its maximum. I was asked to draw 2 cycles of this graph, so I'll put some more evenly spaced lines there. So I go down, up 1 cycle, down, up 2 cycles. So that's a bringing it all together. And different graphs, different values obviously change the graph around. So you have to change the process a little bit. But if you can follow this procedure, then your graphs will turn out very well. And also if you get used to graphing it, then going the other way, once you see the graph, you can extract all of this information out of the graph. So take your time, make sure you spend a lot of time getting to this point. Make your graph look nice. Make sure your tick marks look good. Make sure the maximums and the minimums are clearly on your graph. And the sinusoid axis, make sure that's on your graph. You've done a lot of work to get here. Finish strong. Make sure the graph looks very nice. And I think you'll be kind of happy with the way it comes out. It's nice that all that information can be put into a graph fairly simply. So enjoy graphing them. I enjoy it.